Question 4, clearly a route inspection problem. Few clues here. It talks here about the total of all times. That's something they tend to do, so you don't have to add them all up for route inspection problems. And here you can see must walk along each road at least once. Also here mention of the Chinese postman. So you want the optimal Chinese postman route around the village. So the first thing to do with route inspection problems is to look at the degree or order of each vertex. In other words, the number of ends of edges that go to that vertex. So you can see here A has order 2, B here has 5 edges going to it, so that's got order 5. I'm going to make a note of that. C order 2, D again order 5, E 1, 2, 3, 4, F order 5, G2, H again 5, and I2. I've labelled these because they are the 4 with an odd degree. So I'm now going to list them in alphabetical order. So we have B, D, F, H. The next thing we do is we pair them. So if I write B with D, that means that F must go with H. If I write B with F, then D needs to go with H. And if I write B with H, then D needs to go with F. 1, 2, 3 different possible pairings. We now look for the shortest routes between each of these pairs. So B to D, shortest route between B and D is 10. F and H, shortest route is 12. B and F, B and F, we've got 18 there, 21, 19, so it is 18. D and H, we've got 14 there, 15 there. Always check to make sure there's not a route involving more than one edge that's shorter. There often is in these questions. It's not always the one that looks the shortest, but here it is 14. B to H, well here we've got 16. Is there any way we can do that shorter? No, there isn't, is there? 16 there. And then finally DF, D here to F here, well 18 that way. Is there a shorter way? No, so 18. So we've got these. Now these are the 3 distinct pairings, B with D and F with H, that has a total of 22. B with F and D with H has a total of 32, and B with H and D with F has a total of 34. So we pick the shortest. So our answer to the first bit, find the length of the optimal Chinese postman route around the village starting and finishing at Amal's house. Amal's house is A. We will now be able to find a route starting and finishing at A if we double up these here. So a total of 167 plus 22, and this is minutes. Always write the units of measurement in. It then says state the number of times that Amal passes his friend Dipak's house at D. So D is here. Well, to do this, we actually need to draw in the bits we've repeated. So we're repeating B to D, so I'm going to draw there another edge in to indicate that we've been along there twice. And the same with F to H, we've been along there twice. Every time we visit one of the vertices, we need one edge to get there and one to get away. So if we count the degree and divide it by 2, that will tell us how many times we... For B, we've got 6 edges there. So one to get there, one to get away, that's one visit. One to get there, one to get away, another visit. One to get there, one to get away. So 3 visits. Degree is 6, now that we've added that extra one, so it would be 3. So looking then at D, we have 6, so it's 6 divided by 2 equals 3 visits. Okay, that's the first 6 marks. For the remainder of the question, I've rewritten up here these distances because we'll now be needing them. So here it says Dipak offers to deliver the magazines while Amal's away on holiday. Dipak must walk along each road at least once, so same scenario. Assume that Dipak takes the same length of time as Amal to walk along each road. So same situation. Dipak can start at any vertex and finish at any vertex. Now this does change the situation, because if you can start and finish at any vertex, you want the start vertex and the finish vertex to be odd degree. So that means you're only going to repeat the shortest route between 2 of the odd vertices. So what we now want to do is look for the shortest. And the shortest here is BD. So the shortest to double up is 10. So the length would be 10 plus 167, which is 177 minutes. This bit's a bit tricky. It says state the vertices at which Dipak could finish in order to achieve his optimal route. If we're doubling up this bit here, B and D, that means that the 2 odd vertices we need to start and finish on to mean that we can get rid of them. We want them to be odd, so we don't need to double up, would be F and H. So either of those 2 to finish on. Part C, a further twist on the question. Find the length of time for an optimal route for Dipak if instead he wants to finish at D and he can start wherever else he wants. Well, that means that he needs to start and finish at one of the options with D in here. So either BD, DH or DF. So what we want to do is to look at all 3 and pick the shortest partner for the ones with D in. So 18 there, 16 there, 12, so it's clearly this one, FH. So the optimal route now would add, because if he's starting and finishing there, you would now have to double up FH. So you would finish at D, that means you've got 167 plus 12. The start vertex, well, wants to finish at D, so needs to start at B. And there we are. Quite a lengthy question. Unusual in that there was 2 different bits to it, but again, take note of that. These sort of add-on bits always seem to come up in these route inspection questions.